Today we will be learning how to find algebraic rules based on patterns. So today we're going to be looking specifically at squares made from matches. So here we have a pattern. We have 1 square, 2 squares, and 3 squares. Now if you notice, 1 square is made up of 4 matches, and in the second pattern the first square is made up of 4 matches also. However, the third square is not made up of 4 matches. It is made up of 3 additional matches. So we want to see if we can find some kind of relationship between the number of squares and the number of matches. So to start off, we can make a chart describing what we see. So we're going to, one side of the chart, identify the number of squares. This marker is running out. There we go, number of squares to matches, or M. So when we have 1 square, we have 1, 2, 3, 4 matches. When we have 2 squares, we have 1, 2, 3, 4, 5, 6, 7 matches. When we have 3 squares, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 matches. So now we have written down how many matches are in each square, but let's say we wanted to find out how many matches were in 20 squares. Now you could draw out 20 squares and count it all up, however that would take quite a while. So we want to see if we can come up with an algebraic rule that'll help us make this a lot simpler. So to do that, we need to find some kind of relationship between the number of matches and the number of squares. And if you look at if you look at each square, there is a repeating pattern going on. If you look, there is 1 match. Oops, I just erased it. 1 match surrounded by 3 matches. And if you look here, there's 1 match surrounded by 3 matches, but then that's also followed by another 3 matches to make another square. And if you look here, there's 1 match surrounded by 3 matches, and then another 3 matches follow that, and then another 3 matches follow that. So it seems like the repeating pattern is there is 1 match at the beginning of each pattern, 1 match at the beginning of each pattern, and then plus 3 around it for each square there is. So when we only have 1 square, we have 1 match plus 3. When we have 2 squares, we have 1 match plus 3 plus another 3. So for the second group of squares, it would be 1 plus 3 plus 3. For the second group of squares, it would be 1 plus 3 matches plus 3 matches plus another 3 matches. So if we write this out, and I'll write down the second pattern right there, and then I'll write down the first pattern here, we see that there's a pattern of adding 3. So what we can do now is come up with an algebraic rule to describe this to help us find greater numbers. So if you look at this, it basically means that for every square, you add 3. So we could turn this into a multiplication rule. And the multiplication rule can look something like this. So you're always going to add 1 plus something, and then you're always going to have 3 matches for the amount of squares you have. So let's use S to equal squares, the amount of squares we're using. So 1 plus 3S. So basically, like we just said, that means that for every pattern you're going to have 1 match, which is right here, 1 plus, and then for every square you're going to have 3 matches. So the only way to see if this works is to test it. So I'm going to erase this work over here, and let's rewrite it up here. 1 plus 3s. So first, let's test it on our numbers here. Let's see if when we plug in our amount of squares, we get the same answer. So we'll do the first one. 1 plus 3 times, and our number of squares is 1. And you see that equals 4, which is what we got right here. And if we do it again with 2 squares, 3 times 2 is 6, 6 plus 1 is 7. Oops, that's supposed to be an equal sign. And then if we do it with our last one, 1 plus 3 times 3. 3 times 3 is 9, plus 1 is 10. So we have made an algebraic rule by looking at patterns within the squares, and then we have demonstrated that that algebraic rule works. So now we said, what if we wanted to find 20? Well, let's plug it in. Instead of drawing 20 individual squares and counting the matches, we can just plug it into our rule and get the answer. So I'll erase this out of the way. So 1 plus 3 times our amount of squares, which is 20. 3 times 20 is 60, plus 1 is 61. So for 20 squares, we would have 61 matches. So that's how you can look at the relationship between the amount of matches and squares to find a future term in the pattern.